All right, in this demonstration we're going to demonstrate using these beakers and some water concepts of relative humidity. Now remember, the relative humidity is the amount of water vapor, individual water molecules, in a given parcel of air relative to the number of water molecules that could be in that particular parcel of air. And it turns out that the relative humidity really depends on the temperature. Now it's important to think of air a little bit differently than maybe you usually do. Air consists primarily of nitrogen, 78% nitrogen molecules, another 21% oxygen, that's 99%. The other 1% is just a whole bunch of other stuff we're not going to worry about. But it's also important to remember that those molecules of air are not really interacting with each other. And that means that there's something else in the air too. That means there's space in the air. There's room between those nitrogen and oxygen molecules. And we can put another molecule into that space. And the molecule that we're interested in is water. So think of relative humidity in a sense of how many water molecules we're putting in the spaces between the air molecules, the nitrogen and the oxygen. There's so many spaces in a given volume of air. If they're all filled with water molecules, then we say the air is saturated and the relative humidity is 100%. If there isn't any water molecules in it, then we would say the relative humidity was 0 and all the spaces are empty. But that very, very rarely ever happens in nature. So, here I've got 5 beakers. And let's say that these beakers represent a particular volume of air, and let's say the center beaker here represents a volume of air at a particular temperature. And you can see it's about half full of water. If the entire beaker represents all of the space available to put water, it's about half full. So we'd say the relative humidity in this beaker is 50%, because 50% of the spaces have water in it. But what happens as we warm this air up? As air is heated, the molecules begin moving faster. As they move faster, they spread further apart and the volume increases. That basically means we're making more space. And so if we warm it up a little bit, now the air has this volume. It means it's got more space. And the water is not taking up as much of the available space. See, this is not quite half full. The level is lower in that beaker. If we warm it up even more, say to this size, same amount of water vapor, but now we're making even more space, and you can see that it only fills it up a little ways. Certainly doesn't fill it up halfway. But what happens if we go the other way? So, well, when you warm air up, space increases, the relative humidity goes down. Temperature goes up, humidity goes down, unless there's a source of water vapor to put into it. Okay, what happens as we cool this down? Volume is going to decrease, the amount of space is going to decrease, and so now that number of water molecules is taking up more of the volume. Let's cool it down even more. Now we're back where we started at about 50% relative humidity. But what happens if we cool it down even more? Oh, just about full. Now we're almost at 100%. Almost all the spaces are filled with air. What happens if we cool it down even more? And this point where the relative humidity, this temperature, we're cooling the temperature down. When we reach that point where all the space is gone and the relative humidity is 100%, that temperature is called the dew point. This beaker is completely full. If we continue to cool it down, what's it going to do? Yep, it's going to rain. So, when relatively warm air that has a lot of space in it, when it's around a body of water like an ocean, or in the case of where we live here in the state of Tennessee, we get ours primarily from the Gulf of Mexico, that water is going to evaporate into that warm air, taking advantage of all the space that's available. And then as that warm air rises, because it's less dense, begins to expand, begins to cool off, As that air cools, the humidity is going to go up. When it reaches the temperature where the relative humidity is 100%, that's the dew point, then condensation can begin to occur, and if the conditions are right, clouds will form, and as air continues to cool, as the clouds form and thicken, eventually precipitation happens.